Welcome to this video on cracking encrypted passwords from a shadow file using C++. So let's kind of start with a little bit of pseudocode around what we're going to be doing. A little bit of just to conceptually understand it. Some of the challenges, when you might run into this scenario, etc. So one, this is in the context of ethical hacking. This is to understand, how in a approved scenario, you might take and deconstruct a shadow file. So what's a shadow file? Well, in Linux, credentials are stored in etc shadow. And you can see you've got a whole bunch of default users, and then you've got these three user accounts, which I'm labeling victim, victim1, and victim2. And in this context, let's say, you breached a system, but you have a list of users on that system, and you want to take their hashed credentials and deconstruct them. So the first thing you want to figure out is, what kind of encryption they're using. So if you go and look up the documentation on the, on these hashes, what you're going to find is this $y$ is yescrypt. And that is the latest encryption being used for the shadow files on Linux. So that's probably what you're going to run into in the future. If you use a different, encryption technology, or if you find one that's older, that may be different. But it's all very Googleable. It's all out there on the web. So in this scenario, you've broken a system, you've pulled down this shadow file, and now you want to crack it. You want to figure out what those passwords are. Well, there are three common methods for doing this. The first is brute forcing. The second is a password list, and the third is rainbow tables. And we are going to be tackling the first two. So what is brute forcing? I think most people know what this is, but let's go ahead and just cover it. So brute forcing is you attempt every single password. So we're going to do, plug in A, B, C, D, on out. And then for each one of these, we're going to try AA, A1, A2, A3, and basically cycle through every possible string of characters. And by cycling through every possible string of characters, we will eventually find the right credential. That is very, very thorough. It is very effective to eventually get there, but it is slow. So if you have a more complex password, if somebody's using a 16-character password and you're trying to brute force it, it's going to take a little while to run through, every possible character in 16 characters until you hit the correct value. So then we get to a password list. So we are going to have a password list we're pulling down, and it's going to have, the top million of a set of common credentials. So in a password list scenario, we're basically going to do something like for password in password list, and then, check password. So these are the two that we're going to code out today. And if I didn't say it already, we're going to be coding this out in C++. I am expecting some level of familiarity with the language. We're going to code through it line by line, but I do expect that you already know enough about the language to build and compile things locally. So we're going to try those. Rainbow tables are a little bit faster even than that. So in a rainbow table scenario, you've taken the password list, you've pre-computed all of the hashes for your rainbow tables, for your table of values. And then instead of checking the hash every single time. You're just, doing for hash in hash list compare hash. And actually we should add a little bit here. So for each one of these, we are doing generate hash compare hash with hashed value. So from a logical standpoint, we're either using brute force or a password list, but they're very, very similar for what we're doing under the hood. We are going through a list of values. We're going to feed in some of what we have. We're going to feed in this first chunk of the string, which tells it what kind of encryption to use, and then passes in the salt. And then it's going to try to generate this entire thing. And if it generates it successfully with whatever values passed in, then we have hit the correct value. We found the password. So that's what we're doing. We're going to try brute forcing, and we're going to try the password list. So right out of the box, I'm going to give you a repo with a few things in it. I will have a README that will contain a link to the password list that you can pull down. We're going to have a main CPP that has the includes and then the char set. I just didn't want you to have to type that. And then I'm also going to be giving you a shadow file that you can play with. So if you're not on a machine where you can easily pull or generate one, these should work for the purposes of this tutorial. And then finally, I'm giving you a VS Code tasks.json and settings.json. And this is going to have the appropriate arguments and commands to build and run, compile a main and then run that main for C++. You don't have to use this. I find this very, very convenient because I can basically run my code just by hitting Control-Shift-B. But you can just as easily do this in the IDE of your choice, or just straight on the command line and run these commands. Either way, they will be out there at a GitHub link that will be called YouTube Password Cracker Shadow Starter. And if you grab the starter version of the code, that's going to be everything you need to pull down this password list that I've got here, and then or that's been provided, and then go ahead and get started. So with all of that out of the way, let's go ahead and pause now. Go grab whatever go grab the repo, get set up, make sure you're in a good place to start, and then we are going to go ahead and start coding. So the first thing we need to do is we need to actually scrape the shadow file. So to do that, we are going to have a vector returned here. So standard vector, because we're going to return the hash and salt, and it's going to be a vector of strings. And we're going to call this get hash salt, and we'll say const std string, and we're going to pass in a username. Okay, and then I'm going to start by just return user int main, and we'll go ahead and grab our main method, return 0, and we're just going to call get hash salt. Except I can't return user. We'll leave that alone for now. So here I'm going to go ahead and we'll start with victim 2. We won't need it yet, but there we go. So now we're calling get hash salt. Let's go ahead and start filling this in. So we will say what our file is. So std string file name equals shadow. You could make this dynamic. I decided to just keep it simple and static. We're going to say stream file name, std string line, and then our vector that we'll be returning later of type std string, hash, and salt. Okay. We'll go ahead and check if the file's open. So if not file that is open, std error unable to open file name. Okay. And then we'll just return hash and salt, empty. Okay. Now we are going to go do a search for the values. So while std get line, file and line. We'll say if line.r find username 0 is at 0. So if the first section is the username, then we're going to go ahead and say cout, not count, cout found user username. Just give ourselves some output. We're going to, and then we need to start breaking the file up. So let's look at what's in here. So the username is going to be right after the first colon, and then it's going to be split up by these dollar signs. So the username is up to the first colon. The salt is going to be after this third dollar, and we will want to include this in the value we pull for the salt. So our salt is going to be everything up to here, and then our combined salt and hash is going to be this entire thing. So what we're going to be doing here is doing a finding the positions of the various delimiters and then extracting the appropriate values. So we'll do size t first colon pause equals line.find. Size t second colon pause equals line.find. And first colon pause plus 1. So basically find this line starting from the other colon position. So we'll say, now we'll start extracting. So string full hash equals line dot substring first colon pause plus 1, second colon pause minus first colon pause minus 1. And what are we doing here? So that substring is going to take the start of the substring, and then it's going to take the length of the substring. So if we want to go from the first colon position to the second colon position, we can't just highlight the two positions. We have to actually have the first one go one further because we want the thing right after the colon, and then subtract the first colon position from the second colon position to get the length that we're trying to, the length of the hash field that we're trying to find. So let's go ahead and add some output. So we're going to say full hash field, full hash. All right, and then we're going to find the third dollar character in the full hash. So again, we're trying to get to, we got $3, dollar, dollar, dollar. We're going to find the third dollar in that hash value. So we're going to say size t, third dollar pos equals full hash dot find dollar, full hash dot find dollar. This is a little tricky, so pay attention to where all of the parens are so this doesn't mess you up. +1, +1. All right, that should give us the third dollar sign. So if third dollar pos is equal to in pos, and we're just going to say C error could not find the third dollar symbol. Okay, and the break. All right. Now we're going to go ahead and pull the salt. So std string salt is full hash dot substring 0 to full hash dot find dollar third dollar pos +1, and then we'll do cout extracted salt, and then endo. And then finally, we're going to add our two values to our vector. So we'll do hash and salt dot pushback salt. The order does matter here. And then hash and salt dot pushback full hash. And then finally break. And then down here, we're going to do file.close and then return hash and salt. Okay, so let's go ahead and say we want the same type. So we're going to do and the same value. So let me just copy this standard vector strings hash and salt equals get hash salt. And then we're going to do, we're just going to print the values that we got. So we'll do, let's see. Let's go ahead and set them equal to our variables. So const char star salt equals hash and salt at 0, and then we actually need to call C string on them, which will turn them into that const star or const char type that we need. So we're going to do const char star combined salt hash equals hash and salt 1 dot C string. Oh, not 1 dot at 1 C string. And then we will do, go ahead and print those out. Salt. Okay. And then because we have our task.json set up, I can just hit Control-Shift-B here and we can print. So it grabbed a full hash field and extracted salt, and then we see that salt value and the full hash field. And at least visually, this looks right. This looks like what we expect. All right, next up, we need the function that's actually going to compare and see if a password, hash the password and do a comparison between the hashed value and the password that we're passing in. So before we get into any looping, any of that, we just need to make sure that our hashing and password verification is working as intended. So this is going to be a bool check pass. And I'm using several bools here. What I'm basically going to be doing is having each method return a true or a false, depending on whether it found something, and then use that to bubble up back up the tree here. So we'll say bool check pass, and we're going to be passing in a const char password, const char salt, and const char combined salt hash. Okay. We will be using the crypt library. I originally set out to write this code in Python. I did not target C++ the first time, but I could not find a Python equivalent that supported yescrypt. I finally tracked down that crypt, the C++ implementation of crypt, would do that hash for me, and it may only work because I'm on a system that supports yescrypt already, clearly, since it was able to generate those hashes. But we're relying on that crypt.h library, which informed the language for this solution. So actually doing the comparison is pretty simple. We're going to do char star generated hash is equal to crypt password salt. And we'll do if strcmp string compare generated hash combined salt hash is equal to 0. Then password matches the provided hash. And then else return false. Okay. So before we go any further, let's just do a quick, sort of check by hand here and make sure that the methods we've put together so far are working the way they're intended to. So victim2, let's go check our README. Victim2 should have a very simple password of AAA. So we should be able to call, and I'm going to call it inside cout. Well, no, I won't. We'll just call check pass. And we'll pass it AAA. And we're going to pass it the salt and combined salt hash. So this should check and tell us if AAA is a valid password. And it says AAA matches the provided hash. So just to check, let's do AAB. And it gives us no output, or it gives us our couts, but really nothing else. So I'm going to go ahead. I'll keep those. No, we've got the output further up. I'm going to go ahead and delete these because I don't think we need them, and comment this out. We may use it later. But the first thing we're going to do now, we're going to go ahead and write our brute force method. So let's go ahead and do here bool brute force crack. All right, and this is going to take a const string current. That'll be the current. So we're going to be using recursion for this. So this is going to be the current password passed in. We'll pass in the max length. We'll do const char star salt and const char star combine salt hash. Okay. Bool result equals false. So we're starting out with a false result. If current.length. So what this is going to do, our logic, we're going to generate all possible single character passwords, and then all possible 2-character passwords, then all possible 3-character passwords, and on up until we find the password that we're attempting to get to. So we're going to say if current.length is equal to password length, then we're going to result equals check pass current dot cstring, again to turn it into that char star data type or const char data type, and combine salt hash, and then return result. So at that point this should return true. For char c in char set, and that's the char set value up here. So we're basically going to loop through the characters here. So I've used the word all possible passwords several times. It is worth noting if you were developing this out, for a real application, you would probably want to include more things in your character list. Otherwise, you're going to miss, punctuation in passwords. That's also a wonderful reason to use punctuation in your passwords. Okay, so let's see, where were we? We were down here under brute force crack. So for char c and char set, we are going to do result equals, and this is where the recursion comes in. So we'll say current plus c, password length, salt, combined salt hash. And then if result, which remember this is a bool, so it's effectively saying if result is true, then return result. Otherwise, it's just going to keep looping. All right, that looks good. Let's see. Let's go ahead and call our brute force crack down here. Now again, I mentioned that this is going to check for all things of one size. So let's go ahead and just play with that for a moment. So bool result is equal to brute force crack, and let's say size is 1, salt, and combine salt hash. That looks good. Let's just result. Oh, okay. So found user victim 2, and then it never found anything. So let's go ahead, and we happen to know that victim 2 has a 3-character password, so let's just go ahead and say 3. And, oh, it looks like I accidentally messed up and pasted something there that I did not intend to. Hopefully I didn't cut it from somewhere else. I guess we'll find out in a moment if the code runs. All right, and then it says password AAA matches the provided hash. But obviously we don't know ahead of time, or in a real scenario, we wouldn't know ahead of time if the password was 3 characters. So how do we solve that? We can say int max password length, and let's just make it 16. And then we'll say for int I equals 0, I less than max password length, and I++, we'll give ourselves some output. Starting password list at crack for length I. Okay. And then here, we're just going to copy this up. And instead of 3 here, we'll do I. And then, much like we did before, if result break. All right. So it is running through every possible value here between, 1 character length and 16 character length. And actually, I see a little bit of a logic error here, maybe. Let's see. So it's starting with 0, which gives us an immediate return, but then everything else should be good. So we're running for length 3. And I would normally pause, but I want to give you a feel for how long it takes. Hey, that's not too bad. So password AAA matches the provided hash. So, this is one of the reasons, and that didn't take terribly long, but we also started with a really simple password. 3 characters, all A's, all lowercase, not super complicated, and we only got to a length of 3. If we did something very simple, password 123, like some of these others, even that, being as simple as it is going to take a while. If I go search victim 1, we're going to be sitting there for, you can see it starts to slow down as you hit, 3, 4, 5 characters and up. It will eventually get it. This is guaranteed to get any password with that set of characters eventually, but it's going to get it very, very slowly. And then, you can imagine as complexity goes up, brute forcing a password can take a very long time. So let's talk about the second method that we want to play with here, and we'll just let that run. We'll see if it's able to figure it out as we sit here and code out the second method. So this one is going to be password list. And we will be writing a new method, also a bool, called password list crack. And here we'll be feeding it a string of password file name, const char salt, const char combined salt hash, and then we will do an input file stream for password file name, std string password. We'll go ahead and do bool result false, just so we're starting out with a value. All right, and then we're going to do our checks. So if not password file dot is open, then go ahead and print out an error. Okay, now that we've got our error checking in place, we'll go ahead and say while std getLine, just like we did before, password file, password, result equals check pass, and we'll do password.c string, salt, combine salt hash, and then if result return result. And you can see this was actually much simpler code to write. And then at the very bottom, if it doesn't find anything, it's still going to return result, which will be a false. All right, so you can see we're still down here, and we are still working our way through all of the things with 4 characters. And you know, the reason this is not a problem where difficulty increases in a linear fashion. You know, it doesn't take twice as long to generate everything with 2 characters as it does to generate everything with 1 character. You know, that's going to increase exponentially. So even though this will work, and it will work eventually, it's going to take a very, very long time to get up to those higher values. So I'm going to go ahead and exit out of this since we've written our code, and I'm just going to comment that out for now because we don't need it. And we will run password list crack. And let's go pull down. I'm going to grab this password list here and curl -o, and then I'll just grab the name. You can also just hit this in your browser if you'd rather not use curl. Hit it in your browser and copy it into the workspace. Or you know what? I'll add it to the repo. I can do that. I think it shouldn't be too big for GitHub to let me. There you go. Now the file is in the starter code repo. So we're going to call password list crack 10 million password list top million. We'll pass it in salt and the combined salt hash, and let's just see what it comes back with. Okay, found user victim 1. And remember, victim 1 should have password 123 as their credential. And right here, password 123 matches the provided hash. So as you can see, what would have taken, I actually haven't run this the full length of time it would need to find a password 123 in a brute force method. I imagine you're probably looking at around 30 minutes of wait time, and that is a few seconds with C++ looping over a default password list. So, and then of course it gets even faster if you had pre-computed the hashes. If you were dealing with rainbow tables and you had already generated all the hashes ahead of time and you were just doing a compare, that would be even faster than what we just did, because it wouldn't even have to hash it every single time. So, what does this mean for you? Well, a couple things. One, this was mostly just a fun exercise to run through how you would code something like this from scratch. It should tell you something about, if you haven't looked at your password lengths recently, even, complex passwords, if they're short, can be brute forced relatively easily. If you had a password that was, 4 or 5 characters long, it doesn't matter if it's all zeros or, something very random, someone can still crack it using a brute force method in, 30 minutes, 40 minutes probably. Something I would recommend is either using very long passwords, and if very long passwords are hard to remember, try sentences. Try typing out a sentence that is, random, memorable to you, but isn't going to appear on someone's password list. You can see, and I'll apologize, it looks like there's actually quite a bit of profanity in this password list. I did not write this. It is the top million common passwords here. But you can see that all of these are fairly short. They're one-word things. They're, some of them have letters or numbers added, but they're all pretty much, words or words with a few characters in there. And some of them even get into some of the what you might look at as random, random values. So, but what you're not going to find is sentences. You're not going to find someone out there with every possible sentence in a password list. The search space is too large. As long as you stay away from, first lines of incredibly popular books and things like that, then you're probably pretty good if you can write something out that's easy to remember, and yet incredibly difficult for these kinds of tools to guess. The other thing I'll say is that you would probably, if you were doing this in a real pen test, or even for a class, you would probably use something like John the Ripper, which will do a lot of what we just, everything we just wrote out for you in an already packaged tool. And but like I said, I thought this was fun to write and really interesting to talk through how you would do something like this from scratch, in C++, if you were sort of coding it out, from the ground up. So, if you enjoyed this walkthrough, hit like, hit subscribe. I do quite a few coding walkthroughs. Most of them are related to AI and robotics, but I will occasionally dip into DevOps and security. So, if you like what you see here, stick around, and until next time.